Hello, everyone. Welcome to another Bounty episode of the Day Zero podcast. I'm Spectre, with me is Z, and we'll just jump straight into our topics. We don't have much to bring up this episode. First, we have a really short issue in the form of a missing CSRF check in Flickr's account deletion feature, reported by a sad Hex01 for a $750 bounty. This was due to a change in the authentication flow from when Flickr was bought from Yahoo. Before, a Yahoo authentication code was used as a CSRF token when deleting the account, but in the process of the migration, that authentication code was removed and never replaced with another CSRF check. So this was kind of a weird issue to start us off with. Z,
Oh
you
no,
have a theory though on how this could have happened.
yeah, so for one, we jumped into these topics really quickly this episode.
It's a world
Uh,
record for sure.
yeah. Uh that said, with this issue, I don't think it's that inexplicable how it happened. Like, I could definitely understand a developer who's going through and sees, okay, the Yahoo authentication code, using that login when when Yahoo owned Flickr makes sense. And then during the during the account deletion process, somebody who's porting that code, so when SmugMug bought them, porting the code over, sees, oh, they're using this token here, we're not with Yahoo anymore, we don't use that auth system, I can just get rid of it. And so they just got rid of it, not really thinking that it was a security relevant in that case because they're checking authentication in other ways. And I think it's really more of a signal as to why you shouldn't try and be clever with your code and like be creative and try and kind of give things a dual purpose. Like if you're going to prevent CSRF on something, just use the token. It's a dedicated token. Everybody knows what it's for. Whereas giving it kind of that extra feature in this case, I think is probably why they got caught off by having this account deletion CSRF. Because it's just like, well, it's an auth code. It's for something else, and they don't associate it with CSRF. At least that would be my theory on why that happened. I can definitely understand like a developer doing that. I've uh back when I worked as a dev, I remember we acquired a service and I was going through and doing basically exactly like that. It wasn't a single sign-on flow, but making those sorts of changes, and I could totally see why dev would make that mistake.
Easy to skip over. It kind of falls into that track of the don't try to I want to say like premature optimization. It's kind of not really that, but just kind of in that same idea of trying to be uh, too efficient with what you're doing, and it coming back to bite you later. So, and that's one of your famous mantras. So I thought I'd
Well,
bring that up a little bit.
not mine and not that famous, but yeah.
Okay, it's your famous mantra to me. So
Uh,
that's how I'll say it.
yeah, no, it is. It seems to me just a case of being too clever, trying, like you said, I guess efficiency. I'd say just being clever, but yeah, it's
Outsmarting yourself.
pretty much, yeah. Well, or everybody else who tries to read your code.
Yeah. Now that we have that out of the way, we'll get into the bigger topic for this week, which is OMIGOD, very aptly named. Four vulnerabilities,
I guess it's oh
which
me, would it not? OMI.
OMIGOD? I don't know.
Yeah, I've
You can
I've
say it
been
either way, I guess.
mentally I've been saying oh me god. That's OMI, but obviously they are playing
They
on
are
that
going for the oh
statement.
my god.
Yeah.
Yeah. So that consists of four vulnerabilities in Azure's Open Management Infrastructure, or OMI. That's where that came from. Which, as the name suggests, it's used for managing configurations and settings across remote and local environments, and it's automatically deployed on Azure VMs. And it's funny because we've been covering a lot of topics around Azure lately. Feels like I think like every episode we've had at least a Azure topic, and this one I think we have two of them. Um, so yeah, one of the vulnerabilities here leads to unauthenticated RCE as root. The other three are local privesc to root. They also note this affects a lot of various services because Microsoft uses OMI in the back end for a lot of management services, including Azure Log Analytics, Azure Diagnostics, Azure Security Center, and I think they list out a few other ones as well
Yeah, and
that use
it's
it.
kind of crazy here how this does result in that root code execution and remote root code execution, which is a crazy vulnerability, but I do want to comment that this does require So by default, even though OMI is used quite a bit through various Azure services, by default, it's not exposing this management interface to the internet, except in Azure Security Center and one of the other management interfaces. For some reason, I don't have it up here. Azure Configuration Management. So only within that and Security System Operations Manager is it by default exposed. Otherwise, I think this would be quite a bit more impactful. Not the, I mean, this is really just kind of a stupid issue. The impact as an LP is probably like, especially before it was discovered, if any malicious actors had it, would be huge because it does give you root code execution as basically any user on this, or starting from any user on the system. So, in terms of escalating, definitely has a huge impact there. So I guess actually talking about each of the vulnerabilities, the unauthenticated root vulnerability. Let's see here. Remote code execution as root. Effectively, all that happened with this was that every time a request would come in, this has its own little web service. Request comes in, slash WS man, and you'd include this header authorization header. So that's like your basic auth, HTTP basic auth. So there is digest auth also. I believe this is just using basic where you just base 64 encode your credentials and send them along. And then OMI would see that, it would see the authorization header, and it would look at that and fill in the auth info as like a structure, as an internal structure. It would have its UID and group ID filled in based on the auth info you gave, or it would say you're unauthorized. What ended up happening though is if you just skip that header, which again comes across like that IoT vuln we covered, I think last week, where authentication being optional. If you just skip that authorization header, you're left with it defaulting to just the, I'll say the initialization value, so 0, UID 0, GID 0, which you're familiar with most Linux systems, that's your root user. What they probably should have done and what they recommend here as a mitigation is to initialize those to some like a -1 to some sort of non-existent user. That way, if authorization is skipped, it won't default to root. This is just a case of like default or fail open, and fail open in pretty much the worst way. Skip the auth header, and you're authenticated as root or authorized as root.
Yeah. I think the way you put it is maybe a little bit better than how they had it worded in the article, because I think in the article they called it an uninitialized authentication struct, which would have been a little bit more interesting, I think, if you could just have like uninitialized memory values
Well, so
in
it
there or something. But
it kind of is. The thing is, they zero the memory first.
yeah,
So like they aren't initializing those values, they're using their default, but they are initializing the blob of memory as a whole. So calling it uninitialized is completely fair too. It's kind of a weird ground because the reason why this is such a secure or such a severe issue is because of the default value that ends up getting placed there, because they are in a sense initializing it.
yeah, it's funny because if they didn't zero it, it probably would have been less easy to take advantage of because you
Yeah,
would have
for
had to do
sure.
some work to get it set to 0. So yeah, as you said, the fix there was pretty simple. They just made it so the UID and GID is initialized to an invalid ID off the bat. The
Yeah, they
second bug.
So
Oh,
before we
sorry. Go
move
ahead.
on, I was going to say they actually patched this a month before there was any advisory about the vulnerability, which is an interesting decision. I mean, with a lot of Microsoft stuff, it's Patch Tuesday when kind of everything lands. In this case, they did have the commit hit on the enhanced security, or I believe they had the commit messages enhanced security, kind of indicating that this vulnerability exists to anybody that was surfing the commits.
So I did want to get into that. I didn't. Do you want to get into that now or after we cover the other issues, though? Do you
I
want to
mean,
cover
I
the other
just
issues
brought it
first and then
up.
circle back to it?
Yeah, sure.
Okay. Because I do want to go into a little bit of a discussion about that. Um, but yeah, the second bug was somewhat similar to the first one in nature, though it exists in a different auth flow. This one is in the flow of messages from OMI client, which goes to like a middleware process called OMI engine, which then communicates with OMI server, which is root. A low privileged user can't connect directly to OMI server. It has to go through that middleware app, the OMI engine. So the OMI server has to trust the OMI engine to pass it legitimate authentication information and to have verified the user. The problem is it's possible for clients to send requests that get forwarded to OMI server before any authentication occurs, because OMI engine will take any non-special requests, um, and an execute request is an example of a non-special request, and it'll just pass that along. So again, you kind of have that problem of something being executed as root before the authentication is actually verified. So an attacker can just intercept the request between OMI CLI and OMI engine, strip the auth header, and get root command execution. So um, another meme of an issue like the first bug.
Yeah, and I
Um,
will just comment here on the architecture. It is a somewhat smart architecture in the sense of limiting the attack surface of the OMI server, which is running as root, by causing everything like from user line to go through OMI engine. You are limiting a lot of the memory corruption attacks that can take place against OMI server. And since I believe this is, correct me if I'm wrong, I believe this is C code.
I believe
Um,
so.
I mean, it looks like it. I didn't actually go look at the files, but since C code, you're dealing with memory corruption. Having a need to process through OMI engine is kind of a smart move, but it does create the issue where you need to validate and authenticate the users, and OMI server doesn't have direct access to know who's actually calling it. It needs to trust OMI engine. And OMI engine will always include that authorization in its or the authorization structure in its request, regardless of whether or not OMI CLI provided anything, where we're getting the uninitialized use or the zeroed use. I did find the third bug to be I, the most interesting in my opinion. Maybe the least practical, but still, I think the more enjoyable bug. In this third one, so there were actually four bugs. One of them I don't think is actually detailed in here, because we only get details on three bugs, but they have four CVs. Four of them are LP, and the one is remote code
So
execution.
I think the fourth bug they accidentally hit when they were hitting the trying to pull off the third attack, because they mentioned a use after free. They were triggering in the code path, but
Oh,
they didn't go into any
perhaps.
detail on that. So
Yeah, they don't indicate that that is the bug though, so that they got another CV for, but that would make sense. But anyway, for this last bug that they do cover, it's an issue with once again how the authorization flow works. This time though, it has more to do with who's trusting what input. So as we mentioned, OMI CLI communicates with OMI server, and then OMI server communicates with OMI CLI communicates with engine, which communicates with server. So when a new connection comes in on OMI engine from the CLI, it's going to save that off in its little hash map, its dictionary, um, with like the connection number, and then it's going to take that authorization info that it was provided, if it's provided something, and it's going to send that over to the server to actually validate that information. Then the server replies like, "Hey, yeah, this is totally legit," or it's not. It says like this connection number you gave me, they have a legitimate uh authentication info, or they don't. The problem is it's the same code that processes incoming messages, regardless of whether it's incoming from an OMI CLI connection or if it's incoming from an OMI server response. So that creates a situation where OMI CLI can actually effectively forge the messages from OMI server. and basically say, or they could race the OMI server's response. They send off the authentication request, and before OMI server can reply to it, they can send their own message saying, like, yeah, this authentication attempt was completely successful. Let me through now, please. So the challenge with that, like I meant, I kind of allude to the connection ID. They do need to figure out the connection number in that because that's going to be expected in the response from the server. That said,
Yeah, it's going to
what
get matched
they've
in the hash map.
yeah, so what they've indicated though, it's usually number less than 10. That sounds to me like it's just an incrementing number, so it should be reasonably predictable. If you fail once, maybe make another connection attempt and try some higher numbers until you get it. Uh, I mean, they did say it was usually less than 10, but I do wonder if that just has to do with the fact that they're the only ones testing, like it's not getting regular use. It sounds like a just incremental number to me, which will be predictable.
Yeah. And like I said earlier, they did have some trouble pulling off that attack because they were hitting that use after free in the code path, which I believe they said they reported to Microsoft and they got that fixed. So I think that's likely that's where the other CVE came from. I think to pocket, they wrote a Python script that'll send messages directly through the Omni Engine Unix socket. So basically, just bypassing the engine, as I understand it, so that they can just pock their bug and not worry about hitting that UAF. But yeah, so Z kind of mentioned this earlier, but towards the end, they start talking about Microsoft and they critique Microsoft for what they call irresponsible disclosure. Because the fix for the issue was found in the Git commit history before the patch was released, because that commit was made on August 12th, and the patch wasn't until September. And as he mentioned, the name was very obvious. It was named Enhanced Security, so anyone who went patch diffing could find that and exploit it before Microsoft's official patch was released on September 8th. I find this kind of interesting because I can kind of see why you would call that out. Usually, with popular products that are used like that are open source, they'll try to somewhat obfuscate security fixes by burying them in other changes or something along those lines. Is it fair to assume that that's a requirement, though, for them to do that?
So I
That's
think it's more about what Microsoft's standard has been, which is pushing all of the patches on Patch Tuesday. Um, so that's more what comes down to, and this is a little bit of an interesting case because it is open source. It's not just a deployed product where you just get the update binary and away you go. So that does make it a little bit different, but still having it out, at least with a lot of open source products, when they do make these patches, if they're not trying to hide the commit, they make it known this is a security patch. And let that be known to like everybody that they should update soon. Sometimes even letting a few people know ahead of time that either updates coming or providing the update ahead of time for like major clients or whatever. So just dropping it here and then not even announcing it for a month is a bit excessive. I think regardless of whether or not it's Microsoft, it is kind of breaking Microsoft's normal as far as I'm aware. So in like I mean, it's better that it gets patched than not. Ultimately, like that is what matters. It gets fixed, and one benefit here is probably one of the big users of OMI is Azure, is Microsoft themselves, so they're kind of able to self patch this in a lot of cases, or potentially self patch. I did hear from some bounty hunters that they did go scan for that open 5000 port. Most or had very few cases actually have it open, and most weren't vulnerable. Uh, that said, they didn't actually say any were vulnerable, just that most weren't. So implied being that there were a few still vulnerable, so they couldn't just patch it for everybody. But it is a benefit at least. Microsoft can kind of deploy this patch on their own.
so the way I was looking at the situation was Microsoft basically had two choices. They could either patch it in the source code and then try to obfuscate it, which is security through obscurity, and the same issue still applies. It still could have been found. Or, like you were saying, they don't patch it in the source code, or in the open source repository until the official patch is released, which they could have done, but then is delaying a fix like that from the public branch, that could be questionable too, right? So like I feel like
I
Microsoft is
well,
in a little bit between a rock and a hard place there.
I don't
Um,
agree. So I do agree that it can be a harder, like it isn't the greatest idea either to delay the fix, but that is a decision Microsoft made a long time ago when they started Patch Tuesday. I don't,
yeah, I guess
I
that's
don't
fair.
strictly speaking agree with that choice. I do kind of agree with you. I would rather see things getting patched immediately, but I understand that decision, and there are reasons for it. It's not completely baseless, especially with Microsoft and how a lot of their products go. Um, so I mean, Microsoft made that decision that they wouldn't be doing those immediate patches, or perhaps they do with their open source, and I'm just unaware of critiquing this on this, whereas they're completely following pattern. But no, like I kind of hinted at earlier, I think like having the patches happen earlier is a good thing, but Microsoft's general policy has been delaying them until that, and that is a business decision they have made.
I still think calling it irresponsible is maybe a little bit harsh. Um, but yeah, I mean that is fair to point out with Microsoft. They should be consistent with how they're dealing with their patches. So
Well, if they
yeah,
were going to patch it like this, make an announcement and let people know that such a patch actually landed, I think the silence kind of makes it a little bit irresponsible
it's just that when I see irresponsible disclosure, I think dropping exploits or POCs for
or
non-fixed
dark
bug
white
scene, right?
hat.
Whereas this wasn't really Microsoft trying to drop ODays on their own code or something. It was just it was possible to find it through patch diffing, and I mean that's going to be true of a lot of products. Um, I'm sure there's other things where there's been a patch made in a development branch in a repository that hasn't shipped a release yet, and it's like I don't think I would put blame on them. Um, though, like you said, that the consistency thing matters with Microsoft and how they've made their decision with Patch Tuesdays. But yeah, I just think they were a little bit too uncharitable to Microsoft in the post. But that aside, the attacks are cool. I enjoyed the vulnerabilities that were covered here, and I think they were covered well. They didn't go into like too in depth of detail. They covered like just the right amount. They had some nice visual aids there to understand the architecture. So, yeah, overall, really good blog post, I think.
I mean, for the visual aids, they do have another post. If I can find it on the page. That's more meant for page. That's kind of meant for general public consumption. Uh, I'm just getting a white page.
Yeah, it doesn't look
So
too useful right now.
yeah, that's not. They had some better animations of the attacks and stuff that were actually really consumable. Kind of showed the rough idea without getting into really any technical detail. But I guess I can't show that to you guys right now. But they do have a link on this blog to their other blog posts about it.
Yeah. All right. So up next, we have a web app firewall bypass in Adobe Experience Manager from Vedant to Kale, I think is how you say it. Apologies if I said that wrong. Which yielded a $1 to $100 bounty. Adobe Experience Manager is basically Adobe's CMS solution for building sites and forms and such. The post focuses on two components: the query builder servlet, which is used for, as you guess, building queries to go to the Oak query engine, which are comprised as key value pairs, as well as the dispatcher, which is used for caching, load balancing, and firewalling. So they found a bug where when requesting query builder.json is blocked and usually gives a 404. By adding some other content on the end of it, like a slash or a semicolon and then some arbitrary content, they were able to get access to the query builder servlet when they shouldn't have been able to. Um, so after they managed to get that working, they tried out a bunch of various payloads. They found they eventually found one that worked. I'm just trying to find it on the page here. Yeah, so this payload here, um, for those who are listening, basically it's like a semicolon %0, a CSS file, and then they pass a path. and some other properties like a p dot hits equals full and p dot limited equals -1. Um,
Which might be part of the query builder. I'm not sure about that.
I think it is
Um,
too. They don't really go too in depth on every detail of the payload,
yeah,
but I think that is due to the specifics of the Adobe Experience Manager.
yeah, and I mean, I'm not sure if like it's a .json file. I'm not sure if that's just them trying to bypass the WAF or if that is actually the endpoint for this query builder that ultimately gives them access to like see the files on the file system. You can see where they have pat/etc in their example payload. That said, I mean, we don't get a lot of details about why this vulnerability happened, and it's clearly some sort of confusion happening in the WAF in the rules there, but we don't know why, unfortunately. I don't think this is like a novel idea at all to go and just toss random things onto the URL and see if it gets around the WAF, but I did want to call it out as a well, one, some that did get paid out for. We don't get the bounty amount, or yeah, I guess it was. I have $100 written down, but I don't actually see that
Yeah,
on the page. I
I
think
think he
that's
just put
just
a $ XX, like in the range of $1 to $100.
yeah. So it wasn't a huge bounty. I don't know how well Adobe usually pays out anyhow, but I mean,
I'm gonna be
it's
totally
definitely
honest. I was a little bit surprised they paid out at all. We are talking about Adobe, but
yeah, like I see the $2 bounty for it, so let's assume it's between, $10 and $99 then. I mean, it's a small bounty, but it's still something. I do think it's an interesting little bug though, nonetheless, to see that. And any sort of those confusion things are always a little bit interesting. I'd love to know why this happened. On Adobe's side, I doubt we're going to get that information.
nope,
It's just
we
like
probably
it's a
won't.
reminder of where even fuzzing on the web can be used too. He
Yeah,
does refer to started fuzzing manually somewhere, so not even using a program, just trying it all out.
yeah. I thought that was kind of funny when I saw fuzzing manually. But yeah, overall, it's a web app firewall bypass where you can craft queries, and in this case, they use it to like leak directory and file contents. So it does have some pretty serious impact there. So GitLab is in this week's podcast with a stored XSS found in the main page of projects. This was reported by Jokescar for a $3,000 bounty. Surprisingly simple issue, honestly, considering we're talking about GitLab. Um, the issue is in the repository settings for a group, there's a field for the default branch name, which will accept any text seemingly unsanitized. And that'll be used in two places in the setup page for any new repository that hasn't been initialized yet. So, like anyone who's used GitLab or GitHub or whatever, if you create an empty repository, you'll notice it has that setup page that tells you like steps for initializing the repository and pushing to it with commands or whatever. So that was where the stored XSS would occur. Um, on GitLab.com, the attack was mitigated because they did have a CSP in place, and the researcher wasn't able to get around that. But on self-hosted instances, CSP isn't enforced by default, so they could generate access tokens to compromise accounts. Now, you would obviously need to be able to access a group's settings and take advantage of that to exploit this bug, but the researcher points out you can just invite a victim to your own malicious project that's set up with that page to exploit them. Although for GitLab.com, that CSP protection is still in play. Um,
I wouldn't necessarily rely on the CSP protection here. Yes, it seems reasonably strong if they've done it well enough. You're not going to be able to like load just an external script there, but there still might be other things you can figure out of this. CSP is that last line of defense. The fact that you're even getting there, there's a reasonable chance that somebody can eventually bypass that. Especially you've got, in this case, a very generic cross-site scripting stored. Like put whatever text you want in there. I wouldn't depend on that as a mitigation strategy, but it is that last layer of defense.
yeah. Um, But yeah, I mean, not too much to that issue. Again, it's just a little bit surprising because we've covered GitLab quite a bit in the past. And usually, when we see a GitLab topic, it's a somewhat complex attack. It involves understanding some details of like authentication flow or whatever. But this one was just an oversight on one setting field where there was just no sanitization for it. So um, yeah, this was a very lucky finding. So.
Yeah, it's a little bit surprising that it wasn't discovered earlier, although this page, it's probably one of the lesser viewed pages, just because it is only with a new repo that hasn't had anything created in it yet.
Yeah, it's
Otherwise
not
you won't
something
get
that
the
people see super often.
Yeah, and having a default branch name, I think is a relatively new-ish feature, like, in the last year or so. So that limits the exposure it's had to, but it's still a little bit surprising.
Yeah. All right, so Mattermost is up next with a replay attack. Mattermost being a collaboration platform for developers. It's open source and can be self-managed, but they also have cloud-hosted solutions. This was found by Fuzz SQL BOF and netted them a $150 bounty and some swag, although it seems they haven't quite gotten that swag yet. There's a bit of discussion about that in the comments, which I had a bit of a chuckle about. Anyway, one of the things that Mattermost allows you to do is create a channel, which you can use to post comments into. And it has some of the standard permissions, like being able to make it a public channel, restrict members on their ability to post, stuff like that. Well, this is a permission bypass by a replay attack of sorts. The steps of their POC boils down to capturing a request on a channel you're allowed to post to, then replaying that request on a different channel where you don't have the permissions to post to, and it'll bypass their permissions. It'll let the post go through. I'm not sure on the back end what would have led to that kind of issue. My guess is that there's just no checking on the back end and there's only permission checks on the front end, which seems weird, but I don't see how any check on the back end would allow this bug to happen.
Yeah,
I don't know if you have any theory
it
on that.
feels like another sort of client-side enforced thing. That's kind of the thought I was getting when I was viewing this one too, was that it feels like it's just client-side enforcement. It is also a little bit weird that a replay would get this. Usually, like, some like Discord, when you send a chat message, it would go ahead and send the ID of the chat that you're actually sending it to with that message. Whereas this seems like Mattermost must be doing some of that state tracking on its own to know what you're actually viewing and adding the comment to. Because otherwise you'd need to change something in the captured message to say, like, actually, I want to send it to this channel, which then makes sense that they would get that value and validate it. But when they don't have it, and are doing that sort of tracking on the servers, or are doing that state tracking on the server side, they can think, oh, this check has already been done, and they were able to send this message, therefore it's okay. Like, basically going out of order or getting out of sync from what the server actually thinks the state is. So I mean, I've seen that in a handful of applications. I really hate testing applications that do that sort of longer state tracking. It
Oh,
just
I
makes
imagine it's a
testing a little
nightmare.
bit. Yeah, well, you have to send more requests to do anything. Just makes it more of a pain. And that sort of issue is definitely not unheard of there. I imagine that's what's going on here.
Yeah. Unfortunately, we don't know for sure because they don't go into any detail in the comments about what's going on the back end here. So we can only really speculate there. But yeah, I mean, that's the only thing that makes sense to me is if they're doing some of that internal state tracking and they're just not doing validation on the back end. So yeah. Up next, we have a post from Franz Rosen on Detectify's blog about 3 vulnerabilities they found in Apple products, or rather Apple applications, being iCrowd Plus, Apple News, and Apple Shortcuts, yielding $12,000, $24,000, and $28,000 respectively, for a total of $64,000. This post is a really long post because they go into the background of CloudKit, which is the data storage framework that's being used for those applications. We'll jump into the issues and leave most of the background for anyone who wants to check it out. We'll just cover what's relevant for the issues. because yeah, if we tried to cover everything here, we'd be here a while.
Yeah, and I
So
think the most relevant thing is, like I said, it's just a storage framework. Um, Everything has, two environments, dev and prod. Environments have scopes, private, shared, and public. Public being the concerning one. Well, it's public. Just need to have the public API token to use it. And then inside of that, you've got your zones, which have records for the actual data, or what you would expect to be in there. All of the records have, an in type, text, binary, whatever. That's where you're actually storing the data.
yeah. So the first bug is in iCrowd Plus, which I believe is like a Siri test app. I couldn't find too much information about it. Um, it seemed this issue just seems to be a bad permission set on the public API token for the Phonomo and iCrowd containers that are used by the public.icrowd.apple.com site. It would use the token that was embedded in the site to fetch the current version of the iCrowd Plus application, as well as version information like the description. Well, it turned out that token also allowed you to create your own records as well as modify and delete them, which this guy used to modify the data of the iCrowd Plus website from Apple. So he did that to test that it could work, reported it to Apple, and then deleted the record afterwards. This one just seems like a bad permission set on that token.
Yeah, I mean,
I
all of these issues seem to be based around that idea of just having some sort of bad permission set up. One of them's maybe a little bit more questionable, but in general, that seems to be the issue here. And that's what he stated up front was, as he was learning about CloudKit, it's like, this is really confusing to me. Is it confusing to the Apple devs? Have they made these mistakes also? And then went to go look at it.
Yeah, we've covered a few issues with Apple before, where again, kind of circling back to what we were talking about with the first topic today, they kind of outsmart themselves. They design these really complicated like authentication flows and stuff, and it's easy to get it wrong if it's not easy to use. So, but yeah, this prompted them to look for other bugs, which is where they found the next two. The second bug was in Apple News. This one was a little bit more complex. They noticed the news was served via CloudKit, and all articles were served from the public scope, and the stock app fetched from the same container as well, com.apple.news.public. They wanted to see if there was some way they could find another permission issue that would allow them to access that public container. They first spent some time enumerating the protobuf messages to find methods that would allow modification of the records, um, where protobuf is used for the serialization. There has been some public work on reversing that, which they link to the repository, but it those that work mostly focused on the get type queries, not really on the modification and creation. So they needed to do a bit of the legwork there. After a few days, they did find some methods that would allow modification of records, but they needed an auth token that had access to the private scope to be able to do that modification. Eventually, they were able to find one, which was through the Notes app. Um, the Notes app would talk with the same database that has the containers for the news and stock records, and it gave you an auth token. Now, realistically, you should be isolated to the Notes container, I would think, for these modifications, but for whatever reason, you weren't. It seems Apple just missed checking that, and you could take a request from the Notes container, substitute the container from Notes to the news.public, and you could get access to the news and stock records. Um, Now, luckily for Apple, that token didn't allow modification of existing records or the creation of records, but it did allow you to be able to create channels in the news app, and you could also delete channels and articles. So the impact wasn't as high as it could have been, but you were still able to do things that you shouldn't have been able to do from the notes token. Um,
So are you
the final
sure
bug,
it was the notes token that kind of led to that? The reason I ask is that does actually explain a question that I was having when I was reading this, which was he talks about the three different APIs that are used. Notes and photo uses one. There's the developer one, or like iCloud.developer. Um, and then there was the gateway that was the protobuf one. So oh no, I was a little bit confused as to why he was switching between them. Um, Do you know where it actually stated about the notes token being what he was able to get out of it? Like, I understood that the notes API, or the API notes was using, was kind of letting him do a bit more, but I wasn't clear on exactly why. So I mean that does answer it. I just don't recall that actually in the article.
So I believe I don't think they explicitly state it, but it was kind of implied where they said they captured the notes request and then they just substituted the container. So I read that as they left the authentication token that was being sent in the notes request as is, and then they just changed what they needed to for accessing the news container. Um, so yeah, I can't find anywhere where they explicitly state that that's the case, but I believe it's using the notes token just
Okay,
from
that
what I
would
read.
make sense. That was something I was confused by. So I mean that kind of maybe explains it. Their example requests here though don't even include the token, although he is talking about the auth token a little bit more. So yeah, I think your intuition there may be right.
Yeah. Yeah, that's what makes sense to me anyway. The final bug was in shortcuts, which allows you to create logic flows that can be automatically triggered or manually triggered to perform actions across your apps on Apple devices. And those shortcuts can be shared with others through iCloud links. Apparently, they're pretty well used actually because we'll get into it in a little bit, but there was a mass disruption because of this testing of this issue by accident, and there were a lot of people complaining. I never use them, but apparently it's a pretty popular feature. So the records that back those shortcuts are created in the public scope, and the name of the record is then used as part of the link, which calls into the iCloud CloudKit API to get the shortcut information. Now they tried doing the same kind of attack they did with the second bug by doing a notes request and substituting a container. Um, but this was being investigated after they'd already reported the second bug to Apple, so that didn't end up working because they'd already fixed that. But it did work in a slightly different area, being the iCloud developer website, where you could create and connect to your own container. By capturing one of those requests and substituting the shortcut container in, again, they could get access to the shortcut database. No interesting attacks directly came out of that, though, because the modification of existing records wasn't possible. Some of the records were indexable, which would allow you to query them, but that's all public information anyway, so it's not really a privilege escalation. It did start getting more interesting when they started investigating zones, though. Um, at first, it didn't seem too promising because they were able to create and delete their own zones, but when they tried to delete something like the metadata zone, it would respond with a permission failure message, like user updates to system zones not allowed. But then when they tried to delete the default zone, it worked, sort of. It would respond with a true indicator, but it was weird because the zone still showed up in the zone list, but it was definitely corrupted in some sort of way. Because when they went to investigate more things with Apple shortcuts, they found shortcuts didn't work for them anymore. This kind of freaked them out, and they reported an urgent issue to Apple security about it, saying they were really sorry. They didn't want to trigger mass disruption of the service, because this affected more than just them. This affected like everybody who was using shortcuts.
Yeah, ultimately,
Instantly, there were posts on Twitter and news articles about iCloud shortcut sharing is broken and nobody knows why. So
yeah, ultimately it did delete every shared shortcut that was in the system. I will also mention that when it came to the zones, there wasn't a lot of documentation available on this because officially it seems like their documentation is that you cannot create custom zones in the public. Um, what's the term they use for that? Public environment. So the fact that they even had the metadata zone is a little bit of a deviation from what they were expecting in the first place. They comment that zones were like the last thing they looked at, in part because of the fact that they're not supposed to be anything other than the default zone. And then yeah, you ultimately went try. I think it's commendable, and worth pointing out, like the steps that he did take when testing. You can see, and I mean, this is one of the co-founders of Detectify who did this testing, so I don't expect them to be making like a lot of those really simple mistakes that random bug hunters might do, like RMRFing, root on a production server or something. Uh, he took a lot of steps. When looking at the news, he created his own little news feed and used that as the test environment for like, can I modify things on the news feed? Can I delete the news feed? And in this case, when he wanted to test that permission structure, he was able to create and delete his own, but he wasn't sure if that meant creating or deleting other existing ones. And ultimately, Apple confirmed that if you can create, that is a positive sign towards being able to just delete everything. But like I said, he tried with the metadata, didn't work. Wouldn't have really expected the default one to work. So it's a little bit surprising that it did work. Seemed like it was actually still there because of the fact the default zone was there, but it's likely just has to be there for how their code works. I just thought it's worth pointing out, like he took a lot of steps to prevent any sort of destructive testing. If I were doing this testing, I don't know if I'd have been brave enough to actually hit enter on that test regardless. Often joke that uh let's just say I've heard a story about somebody testing kind of web dev things where you send like your put and deletes to the web server and deciding to do a delete route, and it actually did work when nothing else was working, as like one of those little test cases that like you don't expect it to work. Nobody expects that you can actually just hit like call delete route on a web server and have it delete the web route, but sometimes it does.
Yeah, and if
uh
it does, your client's not going to be very happy.
no.
Yeah.
Just to be clear,
Um,
that's not something I've done. Oh, I want to clarify that. I can still
a
be hired.
friend for sure. Yeah.
Yeah. But I mean that sort of situation. Like speaking, having done the testing professionally, it's always on my mind what can happen here. With bug bounties, it is a lot different too. Like the risks are so much higher because you're testing most of the time in production. At least when I'm doing testing, like I'm sitting there usually in like a test environment. They've set up this area for me to test in so I can be a little bit more out there. So I did want to call, like they took a lot of steps to prevent this. As soon as they noticed something, they reported it, made it clear what happened, explained that. Actually had to kind of explain it a couple times, and they're back and forth with them. And basically just let them know. Like they took a lot of the right steps. Personally, I don't know if I'd been brave enough to do that one, but that's just because I am so used to testing in more of a private environment that if I were even doing the bug bounties, I'd probably just be more concerned in general. I don't blame them at all for making the attempt though. I can't really think of any other way this issue could have been found without having actually just tried it there. I mean, obviously Apple could have found it, but as doing the bug hunting, I can't think of any other way you'd really have come across this one without just having done it.
well, Apple could have found it, but they didn't. So yeah. So that was a pretty scary experience for them. Apple did end up recovering data and restoring the existing shortcuts, though. It did take a few days, so it was a fairly significant outage, but it was very much a mistake. It seems so. Yeah, just unfortunate that that's how it had to be tested. But yeah, with that, we'll get into our last topic here, which is a strange bug in Apache. A straightforward one as far as exploitation goes, but when it comes to root causing it, not so straightforward. This was presented in the form of slides posted on zeronights.ru from Max Dmitriev. Basically, if you sent a curl request to a PHP page hosted by Apache and you sent an invalid content length, I think they demo it with just sending like an X, it would disclose the source code of the page to the client, which is obviously quite problematic. The client isn't supposed to be able to see the server side code. Um, the root cause was as an ignored error deep in the HTTP filtering code. Um, it's a bit funny though, because technically the AP HTTP filter does check the content length header to see if it's valid, and it will throw this like AP filter error code and call bailout on error, which is a function that's supposed to do some debugging statements or whatever, and
Well,
then reject the request.
it writes out kind of that traditional this request cannot be processed or whatever. Like that's where that gets written out is
Yeah.
in the bailout there. And it's not quite, or the way you phrase it, you said HTTP filtering code. It's the filters that run kind of before, like during different parts of the request, you can hook in on the request. It's the filters that run at that stage. So this one in particular checked the content length, said there was a failure, and bailed out. But as you were just saying, they have this case here, so they kick off all of the filter requests, or all of the filters get kicked off, and then there's the return code. If the return code is less than 0, it switches through a bunch of them: -1, -4, -5, -6, -7, and then there's a default that just allows through. Well, the filter error, when there's an error in the filter, that is a -3 return code, which just happens to be missing in here. So it ended up being allowed through, although all of the filters returned early or prematurely. Um, Obviously letting it through, and it talks through a little bit more about how it leads to end up calling the generator and calling the code, but the ultimate result is that you don't end up having like the proper file type set. It doesn't know the proper type of generator to run on this, so it doesn't know that's supposed to be running the PHP interpreter. It thinks, okay, this is a text HTML file. I need to load up HTML file, and so that's what it does. It reads the file and pumps it out, the source code and all, to the user if you give it the bad content link. It dives a little bit more into it. There is a presentation also, although it is only in Russian. I find it interesting now. It's a Russian presentation, but English slides. But I guess that's a little bit beside the point. Yeah, it's a fun issue, but rather non-intuitive, in my opinion.
Yeah, sorry, I was just trying to get the link because I lost it somehow, and the bot didn't post it in chat. Um, yeah, it requires some digging into the source code. Um, the other weird thing about this bug is it seemed to have been fixed by accident in Apache 2.4.44 in July of 2020, but it existed since 2.4.10, which was July of 2014. And the reason it seems this was fixed by accident was because the Apache vulnerabilities page doesn't mention this issue in the version fix list. They didn't really elaborate on how this ended up getting fixed. I tried delving into the source code to try to find what fixed it on GitHub, and I couldn't find it because the code they point out changed before the fixed version they listed, and there's been a lot of code changes in that time. So I'm guessing it was just some inadvertent code change. Um, but like the bailout on error function, for example, it doesn't even seem to exist on like 2.4.43. So it's really hard to try to get to the bottom of what actually fixed this bug. Um, Maybe somebody who's familiar with the Apache code base could shed some light on that. But yeah, I tried really hard. I spent like an hour yesterday trying to see if I could find what the actual fix was, and I couldn't find it. So
Yeah, it definitely seems unintentional here, and that is kind of a problem because it's not it they don't realize it as a security fix, so this didn't get backported.
yep, yep. No
So
advisory, no backport.
there's a reasonable chance that this is still floating around.
There's probably still a lot of servers that are vulnerable to it. Yeah. And it could be a serious problem depending on the target, because if you have any secrets that are directly in the PHP source code and it's not being loaded from like a config or something, those secrets could be leaked if somebody takes advantage of this attack. So
Yeah, well, one of the challenges with a lot of PHP code is you have the code sitting in the web root with how a lot of people design PHP applications. Um, and so because of that, you have a lot of mixing of PHP files that aren't meant to be seen. They just contain like configuration information and PHP files that, execute code for display. You have that a lot, so there's a good chance of significant disclosures from PHP in PHP code like this.
yeah, you might not be able to get code execution on the server or something directly using this issue, but you could get some very valuable, tokens or passwords or whatever out of it that could allow you to pull off an attack. So, um, or just steal the source code of your site. I mean, that in itself is pretty a pretty big issue. But yeah, unfortunately, not too many details on the fixing or anything like that. Um, I do like the slides though. I think the slides did a pretty good job of delving into the issue.
I had a little bit of a hard time following some of it, to be honest. Um, with some of the slides. I mean, they obviously explained it well enough, but trying to follow it, like, because it is a lot of point form, you can kind of get the gist of it. I had some questions, but yeah, I mean, give it a read if you want more. There's a lot of background in here about like just architectural, so I mean, it's worth reading for that if you want to look at Apache in general.
Yeah, there's some notes that can be pulled out of there. All right, but with that said, that's all of our topics for this week. Thank you to everyone who tuned in. You can catch the VOD on Twitch or on YouTube at 6 p.m. Eastern tomorrow. We also have previous podcasts up on Spotify, Apple Podcast, and more links on Anchor. Feel free to join our Discord and follow us on Twitter. Links are down in the description of the video, and our Discord is in the chat for anyone who's here live. But yeah, with that said, we'll be back tomorrow for the binary episode. That's at 7 p.m. Eastern, 4 p.m. Pacific, which is where we'll also cover the Spot the Vuln challenge that was shown in the pre-stream. We'll also put that in the Discord for those of you that may have missed it. Actually, I think Z already put it in the Discord before we even went live today. So that's there for anyone who's interested. And yeah, we'll see you all tomorrow.